Hi, thanks for joining me today to learn a little bit about airflow in an age of pandemics. I want to give special thanks to Ansight, whose computational fluid dynamics you will see referenced throughout this presentation. Let's talk about particulates and airflow. No big surprise that airflow within a space can move particulates around. We didn't care that much about that until recently. In an age of pandemics, particulates, particularly virus particulates, are very important to us, how they travel. So for my 35 years of doing this, I've always thought that if I introduce enough clean air into a space, it will displace the dirty air, which will leave the space, and I can have a clean environment. The reality is, unless I'm very careful about how I introduce that clean air, the dirty air will stay within the space for a very long period of time and just float around for hours, sometimes over 24 hours. Particulates may remain in a space. Let's start off by taking a look at a patient room. This is not an OR, this is just a room with a patient laying in a bed and a visitor standing next to the bed. The computational fluid dynamics model that's created, it's called the spaghetti model. And what it does is it follows every molecule of air within the space and tries to predict where the air will flow within the space. As you can see, we've done a really good job in this case of designing a mixed air system, which really mixes a lot of air. We're creating tons of turbulence in the space. Now let's take a look at what's happening to the patient in the bed. You can see that there's a thermal plume created above the patient's head, and the particles that are given off by that patient, which may include viral particles, are distributed amongst the room around the space, just like the rest of the air particles. And essentially, we've ensured that every person in that space gets exposed to whatever particulate that patient is giving off with this type of design. What could we do differently? What if we moved the supply air down lower in the room and just brought in the air at a lower height instead of the top of the room? Let's watch what happens to the air molecules in this case. This is called displacement ventilation. And what it does is ensure that the warm particulate-laden air goes to the ceiling and is exhausted through some vent or return air in the ceiling grid, and that the patient and the occupants in the room at the 6-foot height are not exposed to the particulates. We're basically inflating the room with clean air up to about the 6-foot mark and then allowing the particulate and dirty air to go to a higher level than that. ASHRAE is a group of HVAC professionals and engineers, and their recent statement is that transmission of COVID-2 through the air is sufficiently likely that airborne exposure to the viruses should be controlled. Translated, that means that HVAC systems are likely part of the problem. ASHRAE's second statement, though, is that we can change things and make it better. So we're part of the problem, we can be part of the solution. One way to do that is to provide really good filtration. MER 14, and this is right off ASHRAE's website, what they recommend. MER 14 is preferred. And the other way is to ensure airflow patterns are adjusted, this is for classrooms in particular, to minimize occupant exposure to particles. So in other words, don't do exactly what we've been doing, which is ensure maximum exposure to particles by creating turbulence and mixing in a zone. So it looks sort of like this. Person on the left getting exposed to the dirty air, mixing all around with the clean air. Person on the right gets the benefit of just breathing the clean air as the dirty air is displaced. And this is what that looks like graphically. Bring in clean air low, let each person's heat plume take the particulate to the ceiling and out of the space. What does this mean for us? Well, it might mean that underfloor systems become more popular because they bring in the air at the desirable low height. It also might mean that we have vertical fan coils that discharge from the bottom instead of the top, or maybe that we have air handlers in the ceiling but duct it all the way down to the bottom of the room. Or maybe that we change the way we do VAV, or maybe that we use VRF in some applications. We're going to need to help architects understand the impact of this information. It's going to change the way we lay out spaces, possibly, especially if we're raising floors within spaces. Another thing that it might mean is that computational fluid dynamics will become more popular or even required. When I went to school many years ago, computational fluid dynamics was done on a mainframe computer, and you would wait several hours or days to get your output. Now it can be run fairly easily by skilled and trained technicians that know how to operate computational fluid dynamics, and we can ensure that we're designing spaces that will not only be comfortable, but that will also be safe. And what else should we be thinking about that we're probably not thinking about today? Thank you for your time and attention today. I'd also like to thank Dr. Kankari, who helped me understand all of this through a brilliant presentation he gave a few weeks ago via ASHRAE. So thanks to all of you. Let's change the world.